Welcome to the Genius Factory. Enjoy the video.
You begin by verifying prerequisites and taking immediate action. Confirm the orbital slot and necessary regulatory clearances, because without them you cannot legally or safely operate. Next, power check the bus. Inspect battery state, solar array deployment, and regulator outputs to ensure nominal voltages. Once done, upload a basic TLE and initial telemetry stream to your ground station so tracking and receipt can start. This lets you close the loop quickly and detect any glaring anomalies early on. You now continue with the complex integration and calibration steps. Activate attitude control and perform course alignment using sun and star sensors to establish stable pointing, because precision here reduces later corrections. Then run communications tests, a frequency sweep, modulation verification, and bit error rate checks under expected loads to confirm link margins. Also validate payload power consumption and thermal baselines against the mission profile, since knowing real-world draw prevents brownouts. Make adjustments iteratively until measurements match predicted values. You finish by running the full end-to-end mission sequence and handing operations to the flight team. This confirms automation and human oversight coexist. Once handed over, start routine monitoring of telemetry, health packets, and orbit decay estimates to catch trends early. If anything goes wrong, isolate the affected subsystem and revert to safe mode immediately to protect hardware. Then download and analyze logs to determine root cause. A single troubleshooting tip: always try safe mode and fresh telemetry capture before re-attempting complex recovery commands.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.